On to the next question, number 41. The armature resistance of a permanent magnet DC motor is 0.8 ohms. At no load, the motor draws 1.5 amps from a supply voltage of 25 volts and runs at 1500 rpm. The efficiency of the motor while it is operating on load at 1500 rpm, drawing a current of 3.5 amps from the same source will be. So we have to find out the efficiency of the motor here. So let's start by writing down what's given to us. So here we have the armature resistance given as 0.8. Then we have the current drawn as 1.5 amps at no load. So let's call that I1. Okay, so this is 1.5 amps. Supply voltage is given as V equals 25 volts and it runs at speed 1500 rpm. The efficiency of the motor needs to be found when the current drawn is 3.5. So let's call this as I2, 3.5 amps. Now in order to find out the efficiency, we have to calculate power. What type of power? 1, we need the total power, and 2, we need the total losses also, because we know that the efficiency is output to input ratio. Total power minus total losses divided by total power. Now let's calculate each one. We'll start with total loss. So here total loss can be written as constant loss plus variable loss. Now constant loss can further be written as power at no load minus armature loss. So let's write down an expression for the total loss here. So total loss, constant loss, let's start with power at no load. Now the power at no load can be written as V times I1 minus, what is the armature loss? Armature loss is I1 square RA plus variable loss. Variable loss is I2 square RA. I hope this makes sense so far. Now let's substitute the values for each one of these terms and find out what the total loss is. Okay. So V times I1, that is 25 into 1.5 minus 1.5 square times 0.8 plus I square R, right? So I square R would be 3.5 square, that's I2, into 0.8. Now when you solve this entire portion, you should get a value of 45.5 watts. Now this is our total loss, 45.5 watts. Now let's calculate what the total power is. Let me just grab another sheet of paper. Okay, so now let's calculate the total power. The total power can be given by the expression of the supply voltage V times the current I2. So that would be 25 into 3.5, and that gives us a value of 87.5 watts. Now let's substitute these two parts into the efficiency. Now efficiency in percentage, let's calculate directly. So that would be the total power 87.5 minus the total losses 45.5 divided by total power 87.5 times 100 to give us the efficiency. So the efficiency would be 48%. Now looking into the options, 48% matches with option A. So for this question, the final answer is 48%.